This is a Honda EV6010 water-cooled generator. The water cooling system is set up so that the water enters the radiator through this hose, travels across the radiator, is returned to the engine through this hose, circulates through the cooling jacket in the engine, flows through the thermostat, which is right here at this position, and in through the radiator. When the engine is running correctly, water will enter the radiator, and these fins right here will shoot with an infrared temperature gauge at about 175 degrees Fahrenheit. They will leave the radiator and shoot on these fins here, right even with the exit hose, at about 145 degrees Fahrenheit. So they should lose 30 degrees across the radiator. When the engine is at the proper operating temperature, the oil filter at the very end here should shoot at approximately 200 to 205 degrees Fahrenheit. The cooling fan on these generators is held in place by 3 bolts. Here's a new cooling fan. Make sure that they are installed so that the lettering on the back of the fan is right side up, because with the lettering right side up, the drain hole for condensation, which is right here, will then be at the bottom. The fan mounts in this radiator shroud, and it blows air out through the bottom, which, if you looked at this frame pan, would be in this hole right here. So if you're checking to see if the generator's cooling fan is working, you would slide your hand underneath the frame pan and feel the air coming out the bottom here. The wiring on the cooling fan is set up so that subwinding number 2 in the stator powers the cooling fan and is set up to charge the generator's charging battery, or the generator's starting battery. The starting battery should be isolated from subwinding number 2 if the starting battery is going to draw more than 5 amps under any circumstances. Subwinding number 2 is capable of putting out about 1.5 amps continuous, or 5 amps maximum. If your starting battery for the generator is going to be a deep cycle like a Marine Group 31 or something like that, and have other DC loads assigned to it, definitely remove the charging circuit. On this generator, the easiest way to do it is that this plug in the stock configuration has 2 wires going to it, one white and one red. Simply remove the white wire. That would be this wiring harness right here, where on this stator, it has not been installed yet or modified, still has the white and the red. Simply remove this white wire, and that'll keep the subwinding number 2 from having to charge the start battery. At any rate, subwinding number 2 puts out 33 volts AC. This diode right here is used to rectify it to DC, and it's about 17.5 volts DC. It leaves the diode assembly through this white wire that's plugged into this relay. The white wire enters the contactor side of the relay. When the generator is running, the coil closes the contactor side and it comes out through this red wire. This black wire is ground. So your red and your black put power to the fan. Incidentally, this diode rectifies the 33 volts AC to about 17 volts DC, but due to the nature of an inductive load, that 17 volts DC is a pulsating DC, so the peak voltage is 17 volts. The nature of an inductive load will pull the peak voltage to RMS voltage, or root mean squared, which is 0.707 of peak. 0.707 of 17 volts is approximately 12 volts. So the fan motor is a 12 volt DC fan motor, and that's why it's used to charge a 12 volt battery, even though if you measure the unloaded voltage of subwinding number 2 after the diode, you'll get approximately 17 volts. At any rate, if this relay fails, the cooling fan will not come on. If the red wire is disconnected, the cooling fan will not come on. Or if the cooling fan motor has failed, it will not come on. If you want to bypass this relay to go to the pre-1996 configuration, you'd simply unplug this plug from the relay, and like on this unit here, put a jumper lead between the heavy white and the heavy red wires. And this way, subwinding number 2, which leaves the stator as the black lead and the white lead, are then connected directly. As you can see, the black lead goes straight through anyway. The white lead then is connected directly to this red lead, so it powers a cooling fan directly. If you check your service manual, that would be section 1, page 6, is the early configuration for the wiring. This generator and this generator are after 1996, which would be illustrated in section 1, page 8 on the wiring diagrams. And let me try to get a shot of this cooling fan installed with decent light. As you can see, the lettering is at the top of the fan and the wiring comes out the bottom. It then hooks around, passes through these 2 wire clips, goes through this retainer, through this grommet, and gets plugged into the wiring harness right here.